Hello, my name is Aaron and I am an incoming junior interested in mechanical engineering and robotics. My second milestone transferred control of the robotic arm to the Raspberry Pi. I encountered some issues along the way, but I am now well on my way to being able to control the robotic arm using the Raspberry Pi. My general process for this milestone included multiple steps. My first step was to get the Raspberry Pi interfacing properly with the servo driver board. I started by downloading the necessary libraries, and then I connected all the proper wires. I then used an online tutorial to help me write a simple test program to try controlling the arm. This particular servo driver board uses the I2C communication protocol, which allows the Pi to interface with multiple devices over just 2 wires. Later, I realized that the servo driver board was not properly driving the servos because I had not yet set the external power supply to supply a voltage. I was using this external power supply to supply power for driving the servos. I then ran my program to manually input different angles for the servos, and the servos responded correctly. My next step was to incorporate the joysticks into the system. This required setting up the analog to digital converter, or ADC. Since the Raspberry Pi cannot read the analog outputs of the joysticks itself, the Raspberry Pi needs a separate board to convert the analog output of the joysticks to a digital input for it. Both the ADC and the servo driver board that I used communicate with the Pi using the I2C communication protocol. It took a little while for me to figure out how to use the ADC properly, but I took my time, checked my wiring multiple times, did research, and asked questions. In the end, I succeeded. After I got the ADC working, I encountered another issue where the ADC kept outputting the same value over and over again. I solved this issue by reconfiguring the power and ground wires for the ADC and joysticks so that they were all on the same circuit. After I did this, the test program worked properly, outputting different values as I moved the joystick. My final step was to integrate the servo driver board and ADC together. Once I completed the wiring for this, I wrote a test program that uses the input of one axis of one of the joysticks to control one of the servos in the arm. The analog output of the joystick goes to the ADC, which converts it to a digital input for my Raspberry Pi. My Python program then uses a piecewise function to convert the value provided by the ADC to an angle to send to the servo driver board, which in turn rotates the servo to the correct angle. The piecewise function conversion step was necessary to correctly translate the position of the joysticks to the position of the servos. The output range of the joysticks is from 0 to 255, while the movement of the servos is restricted to 0 to 180 degrees. This meant that some function was necessary to translate the input of the joystick to the proper angle for the servos. However, the physical middle position of the joysticks outputs a value of about 211. This meant that the conversion from the input of the joystick to the output angle of the servo could not simply be a linear function, because two different conversions were necessary to account for the uneven range of values above and below the center of the joystick. My setup now works as expected, with the position of the joystick being correlated to an angle for the servo. Moving forward, I will finish integrating the remaining axes of the joysticks. Then I will potentially alter my code to have the position of the joysticks determine the speed at which the servos rotate, rather than determining the exact angle of the servo. If I have time, I may also incorporate a pressure sensor to allow the gripper to automatically stop closing when it has sufficiently grasped an object.